Okay, so last time we talked about multiplying and doing these operations with polynomials and algebraic numbers. So let's do a little bit of a review. We had something that looked like this. How did we do that? Okay, we're just multiplying by the 5x. Everything in the parentheses by the 5x. So it's 5x times 7x squared. So you're going to multiply the counts. 5 times 7 is 35. X times x squared is x to the third. And now we have the 5x times negative 3. 5 times negative 3, negative 15. And then we have the x. What we're going to look at today is going to allow us to take that backwards. We're going to look at something like that and ask ourselves, what can we pull out of it to go from this back to something like that? And what we're going to be looking for, the first thing that we're going to be looking for is something called a greatest common factor. Does that sound familiar? It should, because it was on page 2 of your test. So when we're looking at something like this, 35x to the third minus 15x. There are two numbers here. Actually, it was the least common multiple on your test, I believe is what we're asking about, but same type of concept. So anyway, we've got the 35x to the third and the 15x. What is the largest number that'll divide into both 35 and 15? 5. Very good. For the variable, the greatest common factor is the smallest power of the variable. The smallest power, we have x to the third, and we have x. We don't think of it as x to the 1. Which one's smaller? The 1. So that's just x. So it's 5x. 5x is considered to be the greatest common factor. Now, if you recall, with numbers, let's say we were factoring something like 48, and we decided that one of our factors was a 3. What did we do to find the other factor? Divided. 48 divided by 3 is 16. We're going to do the same thing here. We decided that one of our factors is 5x. To find the other factor, we're going to divide by 5x. So do you remember how to do that from Monday? 35x to the third divided by 5x is, what's 35 divided by 5? 7. X to the third divided by x? X squared. Look at this. 3 minus 1 is 2. Then we've got negative 15x divided by 5x. What's negative 15 divided by 5? Negative 3. X divided by x? Cancels out. So there it is. That, 35x to the third minus 15x, factors into 5x times 7x squared minus 3. Notice that was where we had started before. Why do we need to do that? There are a lot of cases, if you get into engineering or business, where you have to be able to factor that out to maximize or minimize, what's the price that you can charge that would give you the maximum profit and stuff like that. Well, most of the time, you're not going to start out with this, and you're not going to multiply it out and factor it back out. Most of the time, you're going to start with something that looks like this. And you're going to go from there. So you're going to start out with that. 28 and 42. What is the greatest common factor of those two? 7 will go into both, but there's a larger one.
But you said we didn't have to have a large one.
In this case, we do. 14. There it is. Remember how you find that if you can't find it? Ask for help. You factor this out. It's 2 times 2 times 7, right? Factor this out. 2 times 3 times 7. What are the common factors? A 2 and a 7. What's 2 times 7? 14. So 14 is the greatest common factor. For the variable, x to the fifth and x to the third, remember we always take the smaller of the two powers, which is x to the third. So we have 14x to the third as one of our factors. To find the other factor, we're going to divide this out. 28x to the fifth divided by 14x to the third. 28 divided by 14 is 2x to the 2. X to the fifth divided by x to the third. 5 minus 3 is 2. Then we've got the 42x to the third divided by 14x to the third. What's 42 divided by 14? 3, so that's positive 3. X to the third divided by x to the third cancels out. So there it is, 14x to the third times 2x squared plus 3. What do you think?
I feel like we didn't want all different language.
Whole new language, huh?
Yeah.
Well, it's not that bad.
Divide.
Yeah, it's just really three really quick, straightforward steps.
No, this is one of those things where you need to look at it at home and pause it. And,
Sure.
You know.
That's fine. We can deal with
That's
that.
why I wish more instructors would do it.
Yeah.
Oh gosh, you're gonna get my big head now.
The true answer to your question.
Makes you think I have one already.
Right?
Whenever it is.
Sure.
We know that.
Where is that on the bottom? 14x to the third. Where is that x to the third coming from?
That's the smaller of the two powers.
Okay. And why?
Well, because when you do these out,
You always take the
it's for greatest common factor, it's always the smaller of the two powers. Because when you're doing a greatest common factor, you're factoring this out. 2 times 2 times 7. Well, x to the fifth is 5x's. 42 is 2 times 3 times 7. X to the third is 3x's. You've got a 2 in common, you got a 7 in common, and you have 3 x's in common. So that's where the x to the third comes from. It always ends up being the smaller of the two powers.
so just always take the smaller of the two powers.
Exactly. Yeah. What's that?
Well, it's fine, but what if the smallest of two powers is 0?
Well, then there isn't a variable then.
But so if you just have, like, for example, 48x to the fifth minus, what, 30? Do you technically x to the fifth is the smallest variable?
Sure.
Sure.
No. If there's no variable there, then x to the 0 is your smallest variable. There is no variable then. I'll show you an example of that here in a little bit. What happens when we do something like this?
Oh, well.
Line them up.
We're going to deal with the 48, the 32, and the 64. If I were to factor 48, 2 times 2 times 2 times 2 times 3. If I were to factor a 32, 2 times 2 times 2 times 2 times 2. A 64, 2 times 2 times 2 times 2 times 2 times 2. You can factor those yourselves using the factor tree if you wish to verify. What do we have in common?
Well, they have a whole lot of
2,
twos.
another 2. Is there another 2? And another 2. How many 2s? 4. 2 times 2 times 2 times 2 is 16. So the numerical portion of our greatest common factor is 16. How about for the x variable? X squared. How about the y variable? Just y. Right there. So now we're going to divide. So we got 16 x squared y is one factor. The other factor is found by dividing. 48 divided by 16. Say 3. X to the
Well,
Third.
third. Yeah, 5 minus 2 is 3.
and
Y.
y to the 7.
Y cancels out. Y divided by y is gone. You're way confused, aren't you?
I am.
Okay.
Yeah, I
You get the 48 divided by 16
Yeah.
is 3.
yeah,
X to the 5th divided by x squared, you're subtracting powers. 5 minus 2 is 3.
right.
And y divided by y cancels.
That's why the second, or, sorry.
No, it's just y and y. We're going to get to y squared in a second. Now we've got negative 32 divided by 16. Negative 2. X to the,
Well,
just x, because 3 minus 2 is 1, so that's just x. Y to the y. Yeah, 2 minus 1 is 1, so it's just y. So we're done with that one. Now, 64 divided by 16. Positive 4, so plus 4. X. Well, x squared and x squared cancel out. Y to the third, because that's 4 minus 1 is 3. So there it is. Beautiful, eloquent, simple. Confusing. I tried to slip that by you.
I would like to see a math problem that makes you cringe.
Another example. I'm going to let you guys try one.
That was going to be me twice.
Try that one on your own. Which one's smaller?
Well, I'd say x to the fifth.
Which one's smaller?
Okay, x to the third and
Yeah.
y to the second.
Which one's smaller? This is y to the what power? 0, right? 0 is smaller than 2, so there's no y in the common factor. The variable has to appear in every term. If it does not, it's not part of the common factor.
Okay, so x to the third.
So x to the third. And how about for the numbers 27 and 36? Would be 9. So 9x to the third is our common factor. So we have 9x to the third, and when we divide that out, we get 3x squared minus 4y squared.
Sweet, I got that one. See, I have my moments.
That'll be nice.
Thanks.
You guys need to try another one?
Yeah.
Okay. So it's all Cody's fault.
Don't speak.
I didn't speak. You should think of it.
He was thinking.
I try not to be
So for this one, the number will be what? 5, x to the third, and y.
What's that one?
We start dividing out, what's left? 3 x to the second plus 5 y to the second. There it is.
Yeah, I totally messed that one up. Wait, can you get on? Yeah, for a second.
Okay. Another process we talked about looks like this. What did we do when we saw something like that? Multiplying those together. How do we multiply them? We could use FOIL. If you liked FOIL, you could do that. Or
Can you say what that is again?
FOIL,
Yeah.
F-O-I-L, first, outside, inside, last.
I know, but I'm not sure whatever I wrote it on here.
So now, 7 times 3 is 21. 7 times x, 7x. X times 3, positive 3x. X times x, x squared. So this is x squared plus 10x plus 21. Or if you preferred FOIL, you have x times x. That's the f. That's x squared. x times 7. Positive 7x. That's the outside. 3 times x. 3x. That's I, the inside. And then 3 times 7 is 21. That's L for the lasts. But you're not done yet. What do we have to do this? We have to combine the 7x and the 3x. So when we look at this, the x squared comes from the first. The 21 comes from the lasts. The 10x is a combination of the outside and the inside. It's the way.
No, I think I like the process, but it's supposed to be.
Oh, you'll like this one eventually. Just give it time. So if we were trying to reverse this process, we would want to, first thing we do, if we ask you to factor this, we would look for that greatest common factor like we did before. But in this case, there are no common factors between those terms. So there is no common factor to take out. So if there is no common factor, then we resort to reverse multiplication, or sometimes called FOIL in reverse, which means we're going to try to split this into two binomials, or two-term algebraic numbers. We know from what we just saw that this first part comes from multiplying these first two things. What are the only two things that we can multiply together to get x squared? X times x. So we know that. And we know that this last number comes from multiplying these last digits together. So 21 can either be 1 times 21 or 3 times 7. Right? So let's try 3 times 7. So plus 3 plus 7. How do we know if that's the right one? Well, we check to see if we get the 10x. Remember we said the 10x is from the outside and the inside. So here we check the outside. The outside is x times 7, which is 7x. We check the inside, which is 3 times x, which is 3x. We add those together, we get, bless you, 10x. Is that what we wanted? Yes, it is. Bless you again. So the factoring of this is x plus 3 times x plus 7, which is what we started out with. So hopefully that's what we end up with, right?
I can even do it the right way if you want me to do it backwards.
Yeah. So let's look at this one. X squared plus 5x plus 6. First step always is there a common factor? No, there is not. So then we're going to try to do this. We're going to do the FOIL reverse. What do we know about these first two? They multiply to make x squared. So x times x. What do we know about these last two? We got to multiply to make 6, right? So it's either 1 times 6 or 2 times 3. Which one do you want to try? Plus 2 plus 3. So now we have to double check. On the outside we have x times 3 is 3x. On the inside, 2 times x is 2x, so plus 2x, which adds up to 5x. Is that what we wanted? Yes, it is. So x plus 2, x plus 3 is the factoring of that. X plus 2 times x plus 3.
Without the lines there, and just looking at it, it makes it easier to come up with the answer.
Does it for you?
With those lines there, I get
Confused?
too much in front of my face. Take the lines away, and my same I got.
Okay. Yeah. Each person has their own different way that they'll see it. So on this one, is there a common factor? No.
Yes.
No. This first one isn't divisible by 2. So no. No common factor. All of the terms have to be divisible by that common factor.
So there is never going to be a common factor.
Not very often. Sometimes, though.
Oh, can you show us that subject?
We will at some point. You're not ready to get there yet, trust me. You need a while. Give me a few minutes. We'll get there, though. We will get there. So we know this is going to be, 2 terms, and we know that the first term is going to be x and x. What do we know about the last term here? We're going to multiply to make 16, which means 1 times 16, 2 times 8, or 4 times 4. Which one do we want to use? 2 and 8. Why 2 and 8? Oh, you're starting to see already that they have to add up to the 10, aren't you? If we double checked it, we've got 8x out here, 2x in here, does add up to 10x. Perfect. So in your notes, do this one quick. Walk me through it.
Well, it's obviously
It's x and x.
and
1 and 24. Is that what everybody came up with? Okay. What's different about this one? There's a negative. Oh no. What's that mean? Still going to be x and x. Well, what this does is when we look at the 12, 12 can be 1 times 12 or 2 times 6 or 3 times 4. But there are other possibilities we haven't explored yet. It could have also been negative 1 times negative 12 or negative 2 times negative 6 or negative 3 times a negative 4. So this one's actually going to be negative 3, negative 4. Because now on the outside, x times negative 4 is negative 4x. On the inside, negative 3 times x is negative 3x, which is a negative 7x. So you have to worry about that possibility that it could be negatives instead of everything being positive. There can be negatives in there. And you know better than that, Cody.
I know. I just got it.
So you guys try this one quick in your note. What do you guys get here? X's, okay. That's all you got? That's it, you're done.
Negative 3 times
Well, 27 would be 27 and 1 or 3 and 9.
3 and 9.
And negative 3 and negative 9. That makes the negative 12. Okay, so now let's make another little twist. You gotta love that by now, right? How about this one? I'm gonna have you guys just take a look at. So we have x and x. I'll give you that part. What's different here again? There's another negative. This is a negative 36, which means to get a negative number, you must multiply a positive times a negative, or a negative times a positive. So that's either going to be 1 and a negative 36, or a negative 1 and positive 36, or a 2 and a negative 18, or negative 2 and a positive 18, or 4 and a negative 9, or negative 4 and a positive 9, or 6 and a negative 6. We can rule out the 6 and the negative 6 right away because they're going to add up to 0. That would be bad.
4 and negative 9.
4 and negative 9. Let's see what happens there. We check this out. X times negative 9 is negative 9x. 4 times x, positive 4x, which adds up to a negative 5x, which is what we wanted. So that's it.
It wouldn't have made a difference if you would have had the
X minus 9 and x plus 4 would come out the same.
So what?
If you did minus 9 and plus 4 would have been the same.
Yeah.
But minus 4 and plus 9 would not be the same. The minus has to go with the 9. Because if you did a minus 4 and a plus 9, this would have been a positive 5x, not a negative 5x.
Do it.
Okay.
I can't.
This is x minus 4 and x plus 9. Well, then the outside would have been a positive 9x. The inside would have been a negative 4x, which would have been a positive 5x. And we don't want a positive 5, we want a negative 5.
Okay.
But if you ever get that, where you have the right number, it's just the wrong sign, positive or negative, that just means you got to switch to positive and negative.
Now what about that X that's already there?
That's there.
I know, but in the answer there was an X. Oh, okay. Forget it.
Okay.
We need that.
What's different here?
You have X.
There's a 2 up there. There's always been an x squared.
Oh yeah, that
Always been an x squared. It's just now it's a 2 instead of just x squared. All that means is going to be 2x and x. Now this is negative, which means these are still going to be negatives. But there's going to be some negatives here. This is positive, which means they're both positive or both negative. So that tells us they're going to both be negative, right? Because to get a positive number here, they either have to be both positive or both negative to multiply up to a positive. Sound familiar? Not at all. When you're multiplying,
right.
a positive times a positive equals a positive, or a negative times a negative equals a positive. So to get a positive 6, it's either going to be 1 and 6, or 2 and 3, or a negative 1 and negative 6, or a negative 2 and negative 3. Well, since this is a negative 7, it tells us it's probably going to be both either negative 1, negative 6, or negative 2, negative 3. Our first instinct is to try negative 1, negative 6. There's a problem with that, though. On the outside, 2 times negative 6 is negative 12x. On the inside, negative 1 times x is negative 1x. That's a negative 13x. Is that what we wanted? No. The negative 1 and negative 6 looked so promising. But it didn't work because we got this 2 up here. It would have worked without the 2. 2 messes things up. So we're going to go to the 2 and the 3. Let's put in a 2 and 3 here. Negative 2 and negative 3. So let's check it on the outside. 2x times negative 3 is a negative 6x. Negative 2 times x is negative 2x, which gives us negative 8x. Well, that's not what we wanted either. Does that mean we're all done? Can't do it? No answer? Go home? Forget about it? No. In this case, because it isn't just x and x, it's 2x and x, or 2x and 1x, if you want to look at it that way. The order that we put these in matters. So we're going to put the 3 first, negative 3 first, and the negative 2 last. Now 2x times negative 2 is a negative 4x, and negative 3 times x is a negative 3x, which makes negative 7x, which is what we wanted. Kind of like a big old puzzle, isn't it?
I didn't feel like I should hire someone to do that.
For the right price, that could happen.
Yeah, you do more.
Hey, that's not technically not against
I'm not going to comment
Could you
on that,
imagine
but
how
it doesn't
good
sound good.
What's that?
I'm not going to comment about that, but it doesn't sound
It doesn't sound good. I'm going to let you guys try this one. We're going to go on break while you try it. So I'm actually going to end the recording here quick.